In the previous lesson, I mentioned that we'll want to be able to solve certain kinds of quadratic equations which are motivated by questions about the graphs of quadratic functions. For example, if we're trying to find the places where a parabola crosses the x-axis, we call those the x-intercepts. So in today's lesson, I want to spend time talking about solving quadratic equations using one of the most important and useful tools for this job. It's called factoring. So let's get started with a problem that starts out talking about parabolas, but quickly moves into an algebraic equation. So here's the example. I want us to determine the x-intercepts of the parabola whose equation is f of x equals 10x squared minus 8x. Okay, so let's make sure we understand what we're trying to find. The x-intercepts of any graph are the points where the graph crosses the x-axis. So that means these are the points that have a y-coordinate of 0. If you're sitting on the x-axis in the xy plane, then your y-coordinate must be 0. So if I'm trying to find x-intercepts, I want to set the whole function equal to 0 and solve for x. And that means I can translate this question about graphs and so on into solving this equation. 10x squared minus 8x equals 0. Now, we want to factor this quadratic that's on the left-hand side as much as possible in order to find these x-intercepts. And the first rule of factoring in these kinds of problems is to factor out the greatest common factor on the left-hand side. In fact, this is always the first thing you want to do when you're factoring, to look for the biggest factor that's in common on the left-hand side, in this case, and factor that out, okay? So when I look at 10x squared and 8x, I want to know what factors or terms do those have in common. Clearly, they both have an x in them, right? There's an x squared, so that's got some x's in it. And there's an 8x that has an x in it as well. So I would be able to factor that x out from both terms. That's a start. Now, what about the numbers or the constants? What can be factored out of a 10 and an 8 at the same time? Well, both 10 and 8 are even, so I know I can factor out a 2, and if I factor a 2 out of the 10, that's going to leave a 5 there. And if I factor a 2 out of the 8, it's going to leave a 4. So I would have a 5 and a 4. What can I factor out of both of those at the same time? Well, of course, you could factor out a 1, but that doesn't really help us. In fact, 5 and 4 don't have any other factors in common other than that 1, which doesn't do us any good. So the greatest common factor on the left-hand side of that equation is actually 2 times x. And so now what I'm going to suggest is that we factor that out and see what happens. The original equation we had was 10x squared minus 8x equals 0. If we factor the 2x out, I would have the following. 2x times the quantity 5x minus 4, and now all of that equals 0. Now, you might say to me, how in the world do I know if that's really the right factorization? So before we go any further, let me just mention this one thing. If you're not sure that you've factored correctly, you can always stop and re-multiply or redistribute the terms and see if you get back where you started. In this case, you could take the 2x times the 5x, and that gives you 10x squared. And you could take the 2x times the negative 4, and that gives you negative 8x. And that's what you started with before. So you're guaranteed that the factorization is correct. 2x times 5x minus 4 equals 0. Now, there's an amazingly important rule which you've probably used for a number of years already that I'm going to use now in order to finish this problem. If you multiply two real numbers together and their product equals 0, then one or both of those numbers that you multiplied together must have been 0 by itself. Now, how do you use that in this problem? Well, look, if 2x times 5x minus 4 equals 0, then this rule tells me that either the 2x equals 0 or the 5x minus 4 equals 0. And now what I've done is I've split this problem into two smaller problems, two smaller equations, and oh, by the way, those two equations, 2x equals 0 and 5x minus 4 equals 0, are easier because they're just linear equations. And you and I have solved linear equations already in this course. So let's solve those two equations separately and then interpret our answers. 2x equals 0 can be solved into, or simplified to, I should say, x equals 0 if you just divide both sides by 2. 2x divided by 2 is just 1x, or x, and 0 divided by 2 is still 0. So the first equation comes up with a solution of x equals 0. What about the second one? Well, 5x minus 4 equals 0 can be converted to 5x equals 4 by just adding 4 to both sides. And if you divide by a 5, you then get x equals 4/5. So we now have our answer. Let's just make sure we interpret it correctly. The x-intercepts of the parabola, whose equation is given by f of x equals 10x squared minus 8x, are the points 0, 0, and 4/5, 0. And the focus here is on the x-coordinates of those 2 points. Remember, the solutions we found were x equals 0 and x equals 4/5. So the two intercepts on the x-axis are 0, 0, and 4/5, 0. Now, we should really confirm that these answers make sense, and to do so, we could do one or maybe two things. We could either plug in 0 and plug in 4/5 for x in the original function, and then see if the output value is 0. That would be fine, and that's actually a very algebraic way to solve that, or to check that. But the other thing we could do, which is more graphical, is this. We could sketch the graph of f of x equals 10x squared minus 8x, and we could actually look to see about where the x-intercepts are. And if you do this, I think it's a great way to try to check. It may not be the most foolproof way to check, but it's a nice visual way to check to see if you've got the right answers. So here's a graph of f of x equals 10x squared minus 8x. It should be pretty obvious if you look at that one of the x-intercepts is at the origin. You can see the graph going right through that origin. But what about the other x-intercept? It looks like it's just less than 1, and that makes sense with an answer like 4/5, because 4/5 is slightly less than 1. And for our purposes right now, it's not a perfect check, but it's close enough. I'm satisfied that we've got the right answer. If you want something that's more airtight, the only way you can confirm 100% that we've got the right answer is to plug 0 in for x in the original function and see if 0 comes out, and to plug in 4/5 for x into the original function and see if 0 comes out. If you do that, you're guaranteed that we've got the right answers. Now, let's move to another type of factoring situation. So the first example I just did was motivated by a graph. Now I want to do an example or two that's not really motivated by a graph. I just want to go right to the algebra, and I want to solve some quadratic equations. So here's the first example like that I want to do. Let's solve x squared plus 18 equals 11x. Okay, the first thing you want to do with any equation like this is to get all of the terms on one side. It's often helpful to have that happen. We'll break that rule a little bit in a couple lessons, and I'll explain why at that time. But for now, let's start by getting all the terms to one side, and I'm going to suggest we get them all to the left-hand side in this example. If I subtract 11x over to the left-hand side, I'm going to have x squared minus 11x plus 18 equals 0. Now the solutions of this equation are identical to the solutions of the original equation. So now let's just focus on this new equation. Remember the first rule of factoring. Factor out the greatest common factor. You always need to do that first. Unfortunately, the greatest common factor of these three terms is actually just a 1, and factoring out a 1 doesn't help me. So although it was good to remember to do that first, I need to just move on because that step really doesn't help in this problem. Now the next thing I want to do to factor this quadratic is to write out what I know. What I know is that it's going to factor as something like x minus or plus something times x minus or plus something else. And those will both be in their own set of parentheses. Okay? But now I need to figure out what the signs are going to be after each of those x's. Will they be a plus or will they be a minus? Maybe they're both plus, maybe they're both minus, maybe there's a mixture. Well, in this case, in order to get that plus 18 as my constant term, as opposed to a negative 18, I'm going to need the same signs after each x. And in order to get an 11x, or I should say a negative 11x, I'm going to need those signs to be negative. So they need to be the same sign in both sets of parentheses, and because I have a negative 11x as the middle term in the quadratic, I need both signs to be negative. So now I know that my factored form looks like x minus blank, let's say, times x minus another blank. And now I need to fill in those two blanks with some sort of numbers. And now I've got to start doing a little bit of arithmetic, maybe either in my head or on a piece of scratch paper over to the side. Whatever numbers I put into those blanks have to satisfy two rules, or two facts. First, the product of those two numbers that I plug in has to be the 18, the constant term. And secondly, the sum of those two numbers needs to be 11. Now, there are lots of choices for the numbers that you could multiply together to get 18. For example, you could do 18 times 1. But 18 times 1, even though its product is 18, the sum is 19, which isn't 11. I need it to be 11. Okay, we could try 6 and 3. 6 times 3 is 18. Cool. But 6 plus 3, that's only 9. I need 11. What two numbers can I pick so that the product is 18 and the sum is 11? Well, if you pause for a second, why don't we try 9 and 2? Because 9 times 2 is 18, and 9 plus 2 is 11. And that tells me what my factorization needs to be. It's going to be x minus 9 times x minus 2, and then of course that was equal to 0 when I rewrite the equation. Now, I've got the product of two things, x minus 9 times x minus 2 equaling 0. Anytime two things multiplied together equal 0, I know that one or the other, or both, have to equal 0. And that means I can split this thing into x minus 9 equals 0 or x minus 2 equals 0. And of course, if you just add the right amounts to both sides of those are the same as saying x equals 9 or x equals 2. Now, I claim that these are the two solutions of the original equation, which we started with a few minutes ago. So I want to check that now by plugging them into the original equation and making sure I get some true statements at the end. So here we go. The very original equation was x squared plus 18 equals 11x. Let's plug in 9, which I claim is one of the solutions, and let's just make sure everything works out. 9 squared plus 18 equals 11 times 9. That's what I would be saying. That's the same as 81 plus 18 equals 99. And of course, that's saying 99 equals 99. That's a true statement. So that's good. That tells me 9 really is a solution. Let's now try the 2. I'm going to plug 2 in for x, and that's going to give me 2 squared plus 18 equals 11 times 2, which is 4 plus 18 equals 22, which is 22 equals 22, and that's also true. So we've confirmed that x equals 9 and x equals 2 are the two solutions of the original equation. Solving quadratic equations by factoring takes a good bit of practice. So let's look at a few other examples of this kind just to try to give you that practice as we walk through this lesson. Let me suggest that you try this one on your own first. Solve the equation 2x squared plus 8x minus 20 equals 5x. Okay, that's a tough one. Let's do it together and see if you came up with what I'm about to show you. It is kind of difficult because of that extra 2, but we can do this. One of the basic rules about algebra and math in general is to try to do things as often as possible in the same way, sort of like following a recipe in your kitchen. Once you've got a good thing going, you don't want to change it up. And the same is true about quadratic equations. So, first things first, let's move all the terms over to one side. I'm going to suggest we move them over to the left-hand side. And that gives us 2x squared plus 8x minus 5x minus 20 equals 0. If you combine the 8x and the 5x, you'll actually have plus 3x. And so what you're really looking at is 2x squared plus 3x minus 20 equals 0. Now, remember the next step should always be factor out the greatest common factor if there is one. In this case, since that 3x is odd and the other two terms, the other two numbers are even, there's no common number that we can factor out. And that 20 on the end by itself, without any x's, tells us that there aren't any x's to factor out either as part of a greatest common factor. So I keep telling you to try a greatest common factor and to factor it out, and we keep running into examples where there isn't one. I can promise there will be some in later examples, so just bear with me as I keep making us go through that step. Okay, what next? Well, let's start writing out these parentheses like we did in the previous example. This time, they are not going to look like an x with a blank times another x with a blank. Why not? Well, because if all you put into the first parenthesis is an x, and all you put into the second parenthesis is another x, then you're just going to have one x squared when you multiply those two terms together. But you need 2x squared in this example. So the opening step that we want here is to actually write two sets of empty parentheses, and in the first one we're going to put a 2x, and in the second one we're going to put an x. So when I multiply those two together, I would actually have 2x squared, and that's a good start. Now, the next thing we want to do is to think about how we're going to get a negative 20 when we multiply the constants together that we want to stick into those two sets of parentheses. Well, we're going to need to have one plus in there, and we're also going to need to have one minus sign. And that's because when you multiply a positive number with a negative number, you get a negative number back, and you want negative 20. So we really are going to want a plus and a minus, one in one set of parentheses and one in another. But which one is going to go with the 2x, and which one is going to go with the x? To be honest with you, off the top of my head right now, I don't know. We'll have to wait and see. But we can play this game of juggling these facts together until we get it figured out. Now, whatever we put in for those two constants, we're going to need to get a 3x for the middle term, and it's going to have to be a positive 3x. Now, you've got lots of choices to make for what you're going to plug in for those numbers. They need to multiply together to give you negative 20, and somehow we need to get a 3x as the middle term. So I'm going to suggest something that you might find a little surprising. I'm going to suggest we just try plugging some numbers in and seeing if the factorization is correct. Seriously, sometimes in mathematics you just have to try and see if what you did worked. So let me make this suggestion. Let's plug a negative 10 in to the set of first parentheses, or the first set of parentheses, and let's plug a plus 2 into that second set of parentheses. That would give me 2x minus 10 times x plus 2. Now, if you multiply that out and it's correct as the factorization, then we should get what it is we want, which is 2x squared plus 3x minus 20. So let's multiply this out and see what we get. Well, you'll have 2x minus 10 times x plus 2. And when you multiply that all out, you're going to have a 2x squared plus a 4x, that comes from 2x times 2. And then you're going to have a minus 10x, which comes from the negative 10 times the x. And then you're going to have a negative 20, which comes from the negative 10 times the positive 2. Well, that's looking pretty good. The 2x squared you want and the negative 20 you want. The terms in the middle, 4x minus 10x, actually gives you negative 6x. That's close, but it's not what we want. What I wanted was a plus 3x in the middle, not a negative 6x. What does that mean? It means the choice of the numbers that I picked earlier, the negative 10 and the positive 2, were wrong. Okay, well, we could keep guessing, and I would suggest you do that until you get sort of practiced at trying to figure out what these numbers are. But let me give you a hint. Let's try this instead. 2x minus 5 times x plus 4. Now, let's just critically think about this for a second. First of all, I needed one of the numbers to be negative and one of them to be positive. I've done that. I needed the two numbers to multiply together to give me negative 20. Negative 5 times positive 4 is negative 20. So I know I'm good there. Now let's try multiplying this thing out together and see if we get the right polynomial. 2x minus 5 times x plus 4 would be 2x squared from the 2x times x, plus the 8x from the 2x times the 4, minus the 5x from the minus 5 times the x, and then minus a 20 times the negative from the negative 5 times a positive 4. When you combine all that together, you'll have 2x squared plus 3x, 8x minus 5x is plus 3x, minus 20. And that's what you wanted. And that means we have factored the left-hand side of our equation correctly. And so our equation can now be written in the following way. 2x squared plus 3x minus 20 equals 0 is the same as 2x minus 5 times x plus 4 equals 0. And remember this splitting trick we can now do. When you have two things multiplied together to equal 0, then you can split them into the first one equals 0 or the second one equals 0. So I have 2x minus 5 equals 0 or x plus 4 equals 0. And that's the same as saying 2x equals 5 or x equals negative 4. And if in the first one you divide by a 2, it's the same as saying x equals 5 halves or x equals negative 4. And that means I now know my solutions. They are 5 halves and they are negative 4. Now, before I move to another example, let's make a couple quick comments. First, there's definitely lots of other choices for what we might have put into those parentheses, and I understand that completely. And so you just need to know up front that some of these problems can take a while. Just be patient and walk through your choices. Secondly, I want you to notice that x plus 4 equals 0 led to the solution x equals negative 4. I've known a number of students who incorrectly conclude that if x plus 4 equals 0, then x must equal positive 4. But that would be wrong, because if you plug in positive 4 for x into the equation x plus 4 equals 0, then you're going to have 4 plus 4 equals 0 or 8 equals 0. And that's just wrong. So remember that you need to switch the sign on the solution the way we did above. If you know that x plus 4 equals 0, then x has to equal negative 4. Let me actually make one more comment before we keep moving. It's going to be very important that your, let's call them arithmetic skills, are up to speed in order to do the factoring of these problems quickly. I needed to know in my head that I had to multiply two numbers to get 20. That means I need to know, okay, 20 times 1 and 10 times 2 and 5 times 4 and so on. I need to know that all of those equaled 20 pretty quickly. You're going to want to have that kind of multiplication and addition facts in your head so that you can do them as quickly as possible. It might be good for you to actually spend some time reviewing some of those arithmetic facts before moving forward with these factoring examples, because it will really help you in the long run as you're trying to keep juggling. Is these two numbers multiplied here and these two numbers have to be added there? Knowing how to do that quickly will be very important. Now, we could probably spend the next 30 minutes doing examples of factoring. It's very important, and these kinds of problems show up quite often. But for now, I want to move on to a slightly different and very special kind of factoring, which is called difference of two squares. So let me show you this with this example. Solve the equation 3x squared equals 48. Okay, let's go through this problem as we have with the previous ones and do the same steps over and over, because as I said, it's like following a recipe. So the first thing we need to do you know what it is? You need to subtract that 48 to the left-hand side so that everything gets on the left-hand side, and you'll be left with 3x squared minus 48 equals 0. That's the first step. Second step, factor out the greatest common factor. And in this case, I've given us an example where there really is a greatest common factor to factor out. It's 3 in this case, because 3 divides the 3 in front of the x squared, and it also divides 48. And that means I now have 3 times the quantity x squared minus 16 equals 0. Now, because I have everything equal to 0, I can now divide that 3 on both sides, and on the left, it just goes away, because 3 divided by 3 is 1. And on the right side, I would have 0 over 3, which is just 0. So what I'm left with is x squared minus 16 equals 0. It's basically like I just canceled out a 3. You might think it's sort of mysterious, like I just erased the 3. I didn't just do that. I actually divided it out on both sides, and it goes away on the left, and the 0 on the right basically annihilates it. So now I'm down to x squared minus 16 equals 0. Now what? Well, I want you to notice that the x squared is a perfect square because it's just x times x. And also notice that 16 is a perfect square since it's 4 times 4. So x squared minus 16 is what I call a difference of two squares. Remember, difference is talking about subtraction. So x squared minus 16 is a difference of two squares. And here's a really cool fact about those kinds of things. Differences of two squares always factor the same way. In this case, it would be x minus 4 times x plus 4. And if you don't believe me, multiply this out, and you'll see that you get x squared minus 16. So it turns out that our new equation can now be written as x minus 4 times x plus 4 equals 0. It's that simple. And using the fact that we already used a few times in this lesson, I can now split that into two smaller linear equations, x minus 4 equals 0, or x plus 4 equals 0. And that means that the two solutions come out quickly as either x equals 4 or x equals negative 4. Now, it turns out that the original equation could have been solved in a different way using square roots instead of using this factoring with a difference of two squares. I'm going to save that for a later lesson. We'll talk about working that kind of a problem out with square roots later. But let's close this lesson with a word problem that gets us thinking about solving quadratic equations in a somewhat real-world setting. Here's the example. Suppose you have a rectangular garden which measures 10 feet by 8 feet. You want to actually expand the garden by, let's say, x feet in each direction so that you keep it rectangular. You can think of this as a new border around the old garden. And you want to plant flowers in this border section, and the labels on the flowers say that they'll fill an area that's 88 square feet. The question is, how wide should you make the border? In other words, what should x be to give you the correct dimensions of this border of your garden? Now, let me ask you a question. What's a formula for finding the area of that border? Well, notice that the border naturally breaks into several pieces of area. There are 4 square pieces on the corners, and those are going to be x squared square feet in area. And there are also 4 rectangular pieces on the borders, and they each have 10x, 8x, 10x, and 8x square feet, respectively. So the sum total of all of these pieces of area is going to be 4x squared for each of the 4 corners. So when you add those up, you get 4x squared, plus 36x for the rectangular pieces on the sides. Now this equals the total area of the border, and we were told that the flowers would take up 88 square feet. So I basically want the solutions of this equation, 4x squared plus 36x equals 88. And now we're back to the kind of problems that we've been looking at for the last several minutes. So let me suggest this. Why don't you try solving that equation, 4x squared plus 36x equals 88? Well, how'd you do? Did you get it? Well, let's just work it through together. Moving that 88 over to the left-hand side gives me 4x squared plus 36x minus 88 equals 0. And if I factor out a common factor of 4, I'll have 4 times the quantity, x squared plus 9x minus 22 equals 0. The 4 will be canceled out when I divide it from both sides, leaving me x squared plus 9x minus 22 equals 0. And that happens to factor as x plus 11 times x minus 2 equals 0. And that could be split into x plus 11 equals 0 or x minus 2 equals 0. So what are our solutions? They are x equals negative 11 and x equals 2. Now, before we say we're done, we ought to think for just a second critically about these answers. What does this x value represent in this problem? Well, it's the width of this border in feet. What does that mean about the solutions? Well, does negative 11 make sense? Absolutely not. You can't have a negative width for this garden. And that means that we should just throw out the x equals negative 11 in this problem. And we need to then make the border of our garden exactly x equals 2 feet wider. And we'll be done. Next time, I'd like to look at a new tool for solving certain types of quadratic equations. That's what we've been doing today, but I want to look at a new tool for doing so, and it involves computing square roots. So you might want to review a few facts about square roots before we move on to the next lesson.